Yeah, this Hadoop training consists about 5 parts, and I'll assume that some of you might have either some background about it, some might be working on it, but I'll assume that we'll start from the ground up, and I'll start from the basics, and then we'll cover up the Hadoop ecosystem components, and during the ecosystem components, the emphasis much will be on the hands-on things rather than theory will be taught at a level so that you can start on your own, but emphasis will be there on the hands-on things. I particularly look at it the way that once you learn these concepts and the techniques, you should be able to apply that in your jobs. That way I would like to model this course path. So the content would be covering the much of the Hadoop ecosystem components, but vis-a-vis, while we are covering the concepts, we'll also be comparing with the traditional systems like enterprise warehousing, cloud, or highly performance computation like that, so that you get the relevancy of the Hadoop big data and why this is emerging, and what is the dire need to understand these techniques. And then once you get into the actual course path, we'll look at the various ecosystem components, popular ones, and I'll also be touching upon the other emerging ecosystem components that is getting embedded into the Hadoop ecosystem. We'll be doing it. And if you look at the part 4, this is the real crux of this course, where this is the practical use in your organizations. Very rarely you see people that they would be either using some of the components at a silo model rather than they will be integrating with each other. So I'll be presenting a lot of samples to you and demos to you about the various integration paths you have, and you can take one or two and do much more research about it or master in that area. So this is about the 4th week, and then the last week we'll be covering upon the Hadoop 2.0. As you know, earlier what has happened till now was called as 1.0, though there are a lot of versions in that. And 2.0 is a game changer. Even the MapReduce also now reformatted to the emerging challenges. So we'll be talking about the Hadoop 2.0 and the contributory ecosystems in that. And finally, you should have some hands-on about Hadoop and its deployment process. So that part I'll be taking it. So I'll encourage you to download a VM of your choice, but I prefer MapR. This is pretty much simplified compared to other ecosystem, but up to you. If you have some VM download with you, that will be fine. Let us get on to the kind of content I'm going to present.
So what is this download, Madhu? Is this something link or something we have? Is that, I think it's an open data source, right?
Yeah, this is the open one. This is around 1.5 to 2 GB. Mm-hmm. This is a company called MapR. We're setting MapR. This is one of the distributions of the Hadoop. As you know, Hadoop is it's open source one in the Apache, but natively, rarely corporates use this native versions. They either go for some distribution company so that they get support for it. Okay. Like among them are Cloudera, MapR, or they ranked in the first 3. The rank might changes between them, but again, Cloudera, where the Hadoop founder is currently staying there, MapR is another company. They entirely rewritten the file system in the Hadoop. Hadoop basically built on Java, but MapR company, they re-architecture the whole thing in C++. So each company has their own flavors when you are looking at the Hadoop. So each company is providing downloads. So I have this MapR download with me, and once you should have a virtual player like this. So this is a completely running virtual machine underneath your Windows 7 or whatever version you're using, Mac or something like that. So you can do all the samples, the practicals, the integration parts, what I've been telling about a while ago. Those things you can do. So once you have understood these concepts and get hands-on in these areas, Now, working in actual cluster is nothing different than doing here. Just that you have much scale there. You're working in a single server, you're dealing with multiple servers. But at practical level, it's same, one and the same. The way the response you would see it, everything would be same. So that is the whole idea. So this is way to actually get hands-on rather than we can speak a lot about it, but again you should have first-hand experience on it.
Okay. Is there any installation?
Sorry, go ahead.
Okay. Is there any installation guidelines we need to know to install this?
Yeah, I'll send you that. I'll guide you through all the process. I'll help you in this.
Madhu, is the PPT available to us to go through, or whatever you are presenting, that's what we have?
Yeah, it is. The organizer will send you that.
Okay.
They'll send you the course content as well as the PPT, the slides, deck also they'll send you.
Okay.
Okay. So let us see some of the sample slides I have kept it. And we'll please stop me if you have any, if you want to know more about it. So this is the sample introductory slides, the way we started from the beginning. I was assuming that some of us might not have any background about big data. So we'll quickly do some brainstorming about it. What is the relevancy between big data and the data warehousing? By definition, someone like to look at it, big data, how it is look like this. And what are the 3V factor in big data? What are the driving forces? Or the conceptual ideas about big data? We'll see these things.
Okay.
So this is about volume, those things. In detail we'll discuss about in the class. So this is nothing related to technology or anything. This is more of a concepts about technology, the big data, excuse me. So if you look at cloud would have some basic conceptual ideas. So like this big data also has some conceptual ideas, so we'll look into that. And also, before even get to the actual technology, so what are the real problems big data is solving it? So we'll see some of the samples here. So before adopting big data or after adopting big data, how this landscape is getting changed, we'll see that part, those things. And also some perspectives we'll leave with this each session, so that you will carry out on this and do something about those things. And this is some of the comparisons I would like to take you on, because if you have some cloud familiarity, this you can easily pick up. These are the basic cloud conceptual ideas. 3 SaaS models: SaaS, PaaS, IaaS are the conceptual ideas, whereas big data has different conceptual dimensions here. So we will look into this in more deeper sense in the actual class. Similarly, if you are coming from HPC background, so what big data and HPC are about, and how we can compare them, those things we'll see. Funny bone. And also, if you like to see, once we have the introduction part, it takes around 2.5 days or 3 days, depending upon all of your comfortness. And then up to this point, we should have some fair idea about the big data and the relevancy of Hadoop being the big data contributor. There are not just Hadoop is the only thing solving the big data problems. There are other ecosystem components. But why Hadoop got popularity, we'll discuss this in the coming session. So it's some history and the basic the ideas about the Hadoop, the qualities about the Hadoop, why it is becoming the more popular offering in the big data challenging space, and the drivers for it. I'll also have other slides about comparing with other emerging slides, like Mist is the other one, and there is a Spark is another framework emerging it. So we'll compare those things with Hadoop. And most of the times it would be helpful for us to understand with comparison, because traditional arguments is there for a while. Most of us, to some extent, we have familiarity. Either you have a deep expertise, you would have heard about high-level concepts. So comparing with some system is very easy to understand a new system. So this is the way I would like to drive the whole sessions. So wherever there is a comparable thing, I would like to compare so that you can easily remember the things, the dimensional things in this new technology. So here also, from the RDBMS world to the Hadoop, how we can compare it, each level, data size level, access level, the manageability the manipulation wise, the schema management wise, the integrity part of it, the scalability wise, so on and so forth like this.
So I heard like in Hadoop you cannot you do not have in RDBMS you have all you write to the table and read and all that. In Hadoop you don't have those facilities. You write them into a flat file all the time kind of thing, or I'm wrong?
You are right, but that is changing now. That is right. That was the initial design, but it's been while now after 6 years of its production. Because somewhere in 2004 this was went into production. I mean to say the corporates embraced it for production usage. Till now, a lot of changes have come. So the design things have matured a lot now. So it can able to cater the read-write files at random read phase.
So does it have any what do you call that? Can Hadoop connect to any environment, to any database? Let's say I have some databases in MAG Pro, some databases in Hyperion, some databases in Oracle, some databases in SAP. So can Hadoop connect to every instance of it?
Yeah, Hadoop natively doesn't connect to anything. As you know, Hadoop it's a framework for mostly dealing with big data kind of problems.
Okay.
You're talking about data connectivity, the integration part of it. That is being done by a component, I would say subsystem in the Hadoop called Scoop.
Okay.
Scoop primarily for connecting the Hadoop with traditional RDBMS systems, and it has totally 11 connectivity so far.
Okay.
I don't know the Hyperion part. Many popular things, SQL, Oracle, MySQL, Postgres, much of things it supports. There is a list of connectivity things, and it is emerging day by day. See, what is happening in this world is that it is not that the Apache Foundation itself developing whole thing. That's not the case. It's a kind of community-based development. The communities who are the product companies, because it is becoming a inevitable for the company to be part of the Hadoop integration, otherwise they're losing the business. So earlier if you look at 6 years, 7 years landscape, it was all restricted. Now IBM had their own closed shop. They don't want to allow anyone to connect the systems. And similarly like that, all the big giants, they never allowed their systems to connect with any other. But it is changing now, because adaptability is so high, becoming so popular, and is solving much higher problems what traditional enterprise can do. So inevitably all the companies, they are developing connectivity components and donating it to Apache Foundation.
Okay.
That's when the Scoop matured a lot. It is supporting 11 connectivity so far, and that is about the RDBMS thing. And apart from it, if you set aside RDBMS and think data as a repository, there are various other things, right? You have document-based databases. You have binary file-based databases. You have unstructured databases. So many things are there. RDBMS is one segment we're looking at it. Yeah.
Okay.
So this is the comparison part, and then this is again recap of the fundamentals. But this will give you a fairly good understanding about. If you have some data warehousing background, this will give you a glance, a high-level glance about it. What Hadoop is able to do with warehousing. Is it a competent or a complementary? We'll see that part.
So in Hadoop also we can perform any kind of ETL that we do in the relational database?
No, that's very generic one. That's not the case always. Any kind, I'm not sure what the boundary you're looking at it. But I would say, let me put it this way. The ETL operations, which involves heavy data extraction and then highly durable transformations, that can be achieved with Hadoop. when I define that one is heavy in the sense that you're not talking about gigabytes or anything, much way beyond terabytes, petabytes, like your landscape. And on top of it, you would like to transform your data, and then finally you push it to some other system. If that is the ETL definition you're thinking about it, yes, Hadoop is that one. Hadoop is the only one for it, I would say.
But so all the manipulation goes behind underneath that. All the manipulation is reading from the file, right? Because Hadoop doesn't maintain any relational data store, right?
That is, yeah, in one aspect that is true, but in different. If you look at the ecosystem components, I think you would change your opinion on that. That's to some extent it is true. Yeah.
So further, then we will see. Okay.
So yeah, these things actually, I'm just quickly flying the flights here. Basically, these things actually will give you. We haven't talked about technology so far. We're only looking at high-level things. What Hadoop can do, what Hadoop cannot do, where Hadoop is going to fit in. Those things we are looking at it. So if you look at these slides, each slide will tell you a story about in what are the context or the scenarios where Hadoop is a good fit. Even if you look at the nowadays, one of the primary driving force why Hadoop got so popularity in recent times. The analytics is not the one we have been hearing from ages. If you look at the warehousing, people who are doing analytics from ages. So if someone would like to categorize the analytics, that is about descriptive analytics or summary analytics. Say I have the data, what is my year aggregate, what is my quarterly aggregate, or what is my comparable aggregate between this quarter, last year quarter, like that kind of summary analytics is the one people are doing it. But with the new era, with the new technology advancements, people are looking at business analytics. That means more of predictability analytics, more of classification analytics, more of clustering analytics. These are the things business see value in that. That's where business get a more deeper insight rather than merely business intelligence. So this is one of the area that actually catalyzes the Hadoop popularity. So we'll see some of the areas here. And these are the areas, if you look at the dimensional part of it, how dimensionality actually influencing the Hadoop and analytics part. It is a volume, the sheer volume, and among that the variety and velocity factors. They're convoluting the analytics in Hadoop here. We'll see some of the areas here. Some of the cost factors we'll see. And these are the alternatives. I was telling you earlier, Hadoop is not only thing that is there in the big data. Spark is the emerging one, Mesos is there, and GraphLab is there. GraphLab primarily for the scientific research. And also, if you are familiar with Indian origin, if you have heard about Aadhaar card, it was leveraging Hadoop in a big way from the day one. It is constituted almost 4-5 years back, right? The day one they are utilizing the Hadoop services a lot. So that is there. We'll into this architectural part. And then once we cover the conceptual ideas, in the architecture part we'll see and again comparing with the known thing is better. So if you are in the AWS world, somebody would developing application, how this look like, those things will compare. In Hadoop world, how the application will look like, those things will compare that. And this is the core footprint of Hadoop, with someone talking about Hadoop. So the green ones are the very core, the foundation steps, foundational subsystems in the Hadoop. The other gray ones are they are the ecosystem they call. That means they are built on top of the green ones. So that is the thing. We will discuss these things. So even if you are a enthusiast, want to learn Hadoop, so if you get a good picture about these components, you are good, fairly good. The reason I'm saying is that there are a bunch very highly dense or populated ecosystem components emerging day by day in each area. For visualization, there are so many components are there. For ETL space, there are components are there. For integration with admin system, there are many components are there. But ultimately, they all boils down to the fundamental core systems. So we'll spend good time on the HDFS concepts, MapReduce concepts, big and high. If you get a fairly good hand on these systems, you're almost done. Rest of all like a breeze for you. That's the extension for you. Depending upon your need of the job, you can take a perspective one and then dig more deep into that. But everyone should have a very solid understanding about these areas, these components. So I'll spend a good amount of time on these things. And again, this is the Hadoop 1.0 context. We'll see what is the architecture here, how this communication happens here, like that. So in each architecture, after each architecture discussions, I'll be sending you samples, not the hello world samples. No, there is a decent size of samples I'll be sharing with you, and I'll be sharing the commands instructions so that you can run on your own. And next day we'll see any doubts are there. We'll discuss this. These are some architectural context diagrams and some data flow diagrams like this, right? So that way it is. Basically, I'll take up a small hello world program and just oversimplify the whole architecture, and then once you have a hang on it, then we'll get into a more complex issues. Yeah. These are some what you can expect from Hadoop, what you cannot expect from Hadoop. Those things we'll see. Alright, so with that part, we could have a fairly good understanding about the basic file system. Now we should understand the runtime part of it. Hadoop has two flavors, right? One is the file system part, that is of distributed nature, so it will have its own characteristics. Similarly, the runtime, that is actually the engine that executes the program you develop it. What is the program? The program called is MapReduce. There is a framework out there. It divides your whole processing into tiny packets and then goes there. The way Hadoop look at a program is that data doesn't move anywhere. It's the program or the computation packet that moves to the data and does the job. So how the happens, that's not the case with RDBMS, right? What RDBMS engines do, if you fire a query, the query will be first examined and then compiled. Compilation also involves about finding out indexes, the execution plan for it, right? Once that is done, what happens is that the DB engine now.
So are we moving with the slides, or we are just on the programming module? Because I see still slide with programming module. Are we still there?
Yeah, I'm there. I just paused it actually. I'm trying to give a background for programming model.
Okay.
So before this slide, the background is that I was actually trying to give a picture about RDBMS world. So in the RDBMS world, what is going to happen is that any query, when you're firing it, or any operation, if you're firing a stored procedure or a query, so essentially the data needed for the query. In the query, you might be joining some tables, doing many of the activities, right? So all the relevant touch points, entities, they would come into memory of the database engine, and then in the memory they will have the processing. Either they do the hash mapping, the B-tree mapping, those things they'll do. But ultimately, it is not that you are going into the table repository place. The tables would have scattered somewhere in the hard disk or somewhere in the SAN drives, right? A typical RDBMS thing. So if you understand in a nutshell, data would come down to the engine part, the processing engine. There the actual processing happens. On the contrary, Hadoop does in different. Once we ingest data into the Hadoop system, data is at rest. Data doesn't move anywhere. What is going to happen is that the program what you write, it could be simple querying it, or it's a very complex processing job. That program, through some mechanism like job client is a mechanism, it goes to the cluster here. At this cluster, this is the main component that actually splits up your program into tiny packets, and the tiny packet splitting happens intelligently, so that each packet goes to the exact the data place where it can get the data and process on that spot, on that locality of the server, and then each contributory part will converge together and finally bring out data for the job client. So this is how it's going to happen. So the client actually sends a packet to the job tracker. This is the receiving gateway in the Hadoop runtime. So this actually splits up the job in tiny packets, and each packet now would flow down to the respective data locations. And there are some components that takes care of processing each packet. And once finally done, everything will be converged together, and then you get final output somewhere. So in this case, size of the data has a little lesser significance, rather that is one of the primary factor in the RDBMS world. As the size of your data, imagine that today you have a table of 10 millions, 1 million, the response time would have some impact. And the table grows to 10 millions or 1 billion, obviously the response time increases. No matter what, you have many indexes on it, the manageability also increases. But because of the MapReduce paradigm, we are splitting up into tiny things. We are taking advantage of parallelism and distributedness. So size will have lesser impact on the overall performance. So we will cover this part and get it done during the course. And yeah, this is the sample program. You will get a fairly decent you get a understanding about how the execution model is going to work. And there are some of the interfaces we have. Primarily, Java is the primary client tool, but if you are good at Python, you can go with Python as well. But on top of it, apart from these two, Peak and Hive provides a high-level abstractions on the MapReduce jobs. You don't have to worry about writing the MapReduce job when you're dealing with Peak and Hive. It generates on the fly.
This Python, Java, and these are all what? The native scripts that Hadoop allows, or what is that?
Could you repeat the question?
I said these Python and Java, these are the native scripts that Java, Python, these are the native scripts that Hadoop allows to write the code?
Yeah, that's correct. Java is the foremost thing, natively supported client. But Python is an extension. You have to deploy some of the jars of Python and you can get it. It's not native, but it is supported. Peak and Hive, it is a subsystem. It's not like Java. It's not alone a client, not just a client. I mean.
So this Peak and Hive, do they come along with Hadoop, or that has a different installs for them?
You are right. They come along with Hadoop, but again they are looked at as a client. They also looked as a subsystem. So many views for this Peak and Hive, many perspectives on Peak and Hive. Okay. This slide basically trying to give an understanding about if you are trying to solve some big data problem, you can achieve through Java and Python. Also, you can achieve at a simplistic way with Peak and Hive, and each one is meant for different use case or set of use cases. We'll see that part. Okay. So I would like to leave in one idea so that you can take it on. Let us say you have developed a network driver. So you are developing a new hardware. Let us say currently we have a network interface card that is supporting 2 gigahertz of traffic, right? Mbps traffic, 2 gigahertz of traffic. But now you are starting a new company where you want to capture 1 terabytes of network traffic. So there is no currently driver available to support that 1 terabytes of network card. So what you do essentially, you go to C++ or C, write an embedded program that can be embedded on the hardware, right? You go to the core level of programming model, right? Similarly, in the Hadoop world, if you want to categorize the programming models, Java is a core level of programming model. The next is a Python. The next is a Hive. The next one is a Peak, like that. That kind of classification you can see. This is one type of view you can get from the model, client model. And there are where distributions are there. I will be comparing the distributions. What is the strength of each distribution? Primarily, this is the native Apache offering. This is the one. This is the native Apache offering. So the companies, they took this the base version, the native version, and then they put their flavors here. And each one they target on some of the areas. So the first one who offered the commercial offering is the Cloudera, and then the Mapr, and now Hortonworks also gaining ground here. So we look at the each of the strength and we'll compare.